This is lesson 14.1, part 3. In this lesson, we're going to demonstrate the Pythagorean identity shown here using a unit circle and sine and cosine, and then we will also verify some other identities. Hopefully you remember from geometry that x squared plus y squared equals r squared is the equation to a circle. So if we use the unit circle and we pick a point on that circle, the coordinate to that point we know has cosine theta, sine theta as its coordinate, and we can determine using the Pythagorean theorem the relationship here. So if we call this side A and this side B and the hypotenuse is C, using the Pythagorean theorem, a squared plus b squared equals c squared. In the unit circle, you know that the radius, which is c, is 1. And since the coordinate at any point on the circle is cosine theta, sine theta, then the a value would be called cosine, so we would square that. And the b value would be sine. And then we can write this in a more convenient way and put the square in here, so then we don't need parentheses. These two statements are the same, but this is one of the Pythagorean identities. So here are the rest of the Pythagorean identities, and you should hit pause and write these down. And now we're going to verify a couple of these identities. So we're going to work on the left side, and we're going to use our basic identities to verify this. So the tangent of theta we know is sine theta over cosine theta. So since the tangent was squared, the sine and the cosine are both squared. And then we can get a common denominator, so we'll multiply the 1 by cosine squared over cosine squared. Okay, so then we have a common denominator, so we can add our numerators. Over cosine squared theta. From the previous page, we know that cosine squared theta plus sine squared theta equals 1. So we have 1 over cosine squared theta. And one of our basic identities says that 1 over cosine squared is equal to the secant squared. So we have just verified that identity. Okay, here's another similar one. I'm not going to take the time to do this one. You can try this one on your own. We can also use identities to verify other identities, such as this one. So what we can do with this is, let's see. Okay, let's take our tangent and turn it into sine over cosine. And then let's get a common denominator, so we'll multiply this right side by cosine squared theta over cosine squared theta. So we have a common denominator. So now we have sine squared theta minus sine squared theta cosine squared theta over our common denominator. Okay, then we can factor out a sine squared theta from each of the two parts to the numerator. So that leaves us 1 minus cosine squared theta. And then we can regroup so that we have sine squared theta over cosine squared theta times 1 minus cosine squared theta. Here, sine squared theta over cosine squared theta is tangent squared theta. That's one of our identities. And 1 minus cosine squared theta is one of our Pythagorean identities, which equals sine squared theta. So we have verified left side equals the right side. Okay, for our last example, we're just going to take this multiplication problem and simplify it using identities. So we know that the cosecant theta is equal to 1 over the sine of theta. And we know the tangent of theta is equal to the sine theta divided by the cosine of theta. So the sine thetas can cancel. That leaves us with 1 over cosine theta. And 1 over cosine theta is an identity. It equals the secant of theta. So what we have just determined here is that the cosecant theta times the tangent of theta can be simplified to the secant of theta. That's it for lesson 14.1.